Hello student, this is the second class of basic electrical. In this class we discuss about the parameter of the basic electrical engineering. Parameters. Okay, then parameters of a basic electrical engineering, that means the circuit of electrical engineering is made by the sources and parameters. Okay, then in this parameters there is a resistance, inductance, and capacitance. When resistance look like this is the resistance and it is denoted by R and unit is a ohm. And this is the inductor, this is the coil and it represented by L and unit is a Henry. The capacitance, this is the capacitance and it is denoted by C and unit is a microfarad or farad. Generally the unit of the capacitor is a microfarad. Right? Then three parameters in an electrical system. The first is the resistance, second is the inductance, and third one is the capacitance. The resistance is not capable, if you analyze the characteristics of the resistance, there is no capable to store any kind of electrostatics and electromagnetic charges. It is the real value of a parameter. If you apply the DC, then the resistance value does not change. If you apply the AC, the resistance value is the same. But in an inductor is an electromagnetic storage device. When you apply the AC or when you apply DC, the behavior of the inductor is different. Similarly, the capacitor is an electrostatic storage device and it capable to store the electrostatics charge. Then it's also the affected by the DC frequency. The behavior of the DC and behavior of the AC is different. So now let us see what is the behavior in a DC of inductor and capacitor. Then DC, then the frequency is 0. AC, there is some frequency that is I assume here. This is the omega, and omega is equals to angular frequency radian per second. Then the omega is equals to 2 pi f. F is a frequency in hertz. Okay. Then here is a omega. Then inductance affected by the AC supply, that is see the XL, that is the inductive reactance. It calls a inductive reactance. Okay, and unit is omega and the value is omega L. And the value the omega L. Then if you in the DC, omega is equals to 0 because of F equals to 0, then XL equals to 0. Then if the XL equals to 0, then the behavior of an inductor, the XL is 0, then it's omega is 0, then XL is 0. That means in a DC, the inductor behave like a short circuit. Okay. Then here is a XC. XC is equals to capacitive reactance. Is also omega. This is also the omega. Okay, and the value of the XC is equals to 1 by omega C. Then the omega is 0 in a DC case, then it or Xc is equals to infinity and it's behave like a open circuit. That means when you apply the DC, this is the short circuited, when you apply the DC the capacitor, it behave like a open circuit. But when you apply the AC frequency, it has certain value that is dependent on the value of L and omega. What is the omega here? And similarly here. Then resistance, the resistance is a R equals to rho L by A, that the rho is a conductivity of the material and L is the length of the conductor and A is the cross sectional area of a conductor. Then this is the three parameters, and the inabilistic electrical, the networks and circuit made by this three parameter with the sources. And supposed to be the resistance in series. Suppose three resistance in series, then what is the total resistance? R1, R2 and R3. Then what is the equivalent resistance? Equivalent resistance is what? Then it's a summation of 3. When it will be series, then it's a summation of 3 R1 plus R2 plus R3. But suppose to the R in the parallel, the same value of resistance R1, R2 and R3 in parallel, then what is the equivalent resistance? What is the equivalent resistance? Then in this case, what is the R equivalent? Then R equivalent is equals to 1 by R1 plus 1 by R2 plus 1 by R3. Is the 1 by R equivalent. Okay. And this is the procedure to find out the resistance in series and parallel. Similarly, if the inductor in series here, the series, this is the inductor in series, L1 and L2, then L equivalent is equals to L1 plus L2 if there is no mutual inductance. If the mutual inductance, we considered here the mutual inductance between these two self-inductance, L1 and L2. But if the mutual inductance is 0, then equivalent inductance is L1, L2. But if it is the L1 and L2 in parallel, then similarly it's the L equivalent is equals to L1 into L2 divided by L1 plus L2, like this. Okay. And then capacitance. So suppose the capacitance in series, here is the capacitance in series C1 and C1 and C2, then C equivalent is equals to C1 into C2 divided by C1 plus C2. But even the parallel, the capacitors are in parallel, then C1 and C2, then equivalent capacitance C equivalent is equals to C equivalent is equals to C1 plus C2, like this. Then in this class I will stop here today. Next class we discuss the another kind of the sources. Thank you for watching my video.